So, what we're going to look at today is volume. So, if we think about what we mean by volume, so volume. So, we have length. Okay, so let's say length is in one direction, and that's centimeters. And we can have area, which has two dimensions. So it's like this, and again, like let's say its unit will be centimeters squared. And now we can have volume. So we have length by breadth. So we have three dimensions. And as you can see here, what's happening is this number here is increasing each time. So when we're dealing with volume, we're dealing with three dimensions. Now volume can be thought about as well as, like, if you take an object that has a particular volume, it's also known as its capacity. So for example, the capacity of a fish tank, how much water it can hold, the capacity of it. So if we have a look here, so what we have here, so we have a small tower that's made of cubic bricks. So the bottom layer contains four, if we have a look here, so it contains 4 bricks by 2 bricks. Okay, so it's 4 multiplied by 2, so we have 8 bricks. So we have 8 bricks. And if we have a look here, it's 3 layers high. So we have 1, 2, 3. So we have 3 layers of 8 bricks. So therefore, if you think about what we have in total then, so we have 4 by 2 multiplied by 3, which is equal to 24 bricks. So we have 24 bricks in total. Now, if we were to think about each brick, so let's say if we were to look at one of these bricks, and let's say it was one, so it's 1 centimeter. So let's say the width of one brick, or the length of a brick, is 1 centimeter. So then what we're saying then is that each brick then would have a capacity. So if it's 1, so let's say we have our brick here. Okay, it's not good. Okay, so it's going to be 1 by 1 by 1, okay, which is going to be 1 centimeter cubed. So each brick has a capacity of 1 cubic centimeter. So then we want to know, like, what's the total volume of the whole tower. What we can do then is we can take this, so that's the capacity of 1 brick. So we just have, let's say, just one of these bricks that we have here, and we have 24 of them, so we can multiply by 24, and therefore the capacity of the whole tower is going to be 24 cubic centimeters. And this essentially, if we think about what it is, it's a rectangular box, okay, and then this here is a cubic box. So what we can do is we can derive like simple formulas from this then. So if we were to think about the area of, if we're just looking at one of the boxes, let's say within this tower, so area is going to be equal to length cubed. Okay, so all we've done is we've taken our box, one of our boxes. Imagine this is one of the boxes. And we know that it's 1 centimeter, 1 centimeter, and then let's say 1 centimeter across here. So you multiply the lengths by each other so that all the sides of the box are the same. So the area is going to be the length cubed. So it's what we've done here, length by length by length. So that's the volume of a cube. And then if we think about what we've done, if another way that we can look at it as well is if we think about here, when we worked out the number of bricks. We could also just use the dimensions as well. So we could say, let's say if we use the dimensions, it would be, so it's 24 bricks, or which is equal to 24 centimeters cubed, because each brick is 1 cubic centimeter. So another way we can say then, if we wanted to, if we are dealing with a rectangular box, okay, so let's say if we have a rectangular box, the area, or sorry, the volume is going to be given by length, by breadth, by height. So if we think about, so we have the height, so that's the height, we have the breadth, okay, and then we have the length. So the volume, if you're dealing with a rectangular box, the volume is going to be length by breadth by height. So if we have a look here, so we can see that, so if we look at this, so what we have here, we have a net of this cube, okay, and its length is L, okay. So the area of this, if we take this cube here, so the area is going to be six times the length squared. So this is when we're dealing with area. So let's say each one of these boxes has an area of L squared. So remember area. So then its surface area, if we add up all of the areas of each part of the box, the surface area is going to be given by this here. So that's area or surface area. Now, we can also work with the volume then as well. So the volume, which is V, is going to be equal to the length cubed. So again, that's it's just a general rule. So this is surface area, and this is the formula for getting the surface area, 6 times the length squared, and then this is the formula for getting the volume of a cube. And then if we have a look at this then, so this here, so again, like this is a net, we have a net here. So we've just taken this shape here and we've split it down into its 2D shapes. So if we want to figure out the area of this one, okay, so the surface area, is going to be, we can use this formula, A is equal to 2 times length by breadth plus length by height plus breadth by height. And if we're dealing, so that's the surface area. Now if you want to get the volume, so the volume then is going to be, volume is equal to length by breadth by height, length by breadth by height. So it's just this here. So another way that you can kind of think about it as well, if you take, or a more general way to look at it, like volume is equal to area by height. Now this will work for any shape who has who its cross-sectional area is uniform. So what we mean by that is, like if you were to cut, that's it, if you were to take this shape here and you were to cut it into slices, so that the cross-sectional area, it will be uniform the whole way through. So it doesn't matter what way you cut it across, and what's going to happen is you're going to have the same. So let's say if you cut a slice across here like this, and then you cut another slice across here like this, and then if you were to compare those two slices, they're going to be exactly the same. They're going to be uniform when you look down on them, let's say the cross-sectional area. So when you have something like that, when you have a uniform cross-sectional area, you can get the volume or the capacity of that shape by using this formula. So the volume is going to be the area, so you can get the area of the shape, let's say of the face of the shape, and then you can multiply it by its height. Okay, so let's have a look at a couple of type of questions that you could be asked that relate to this topic. So here we have a rectangular box. So we have a rectangular box here, and it has length 6 centimeters. It has breadth 5 centimeters, and it has a height of 3 centimeters. So what you've been asked to do is to find the volume. So if we remember, volume is going to be equal to length by breadth by height. So if we take this example here, it's going to be, so volume is going to be 6, we can put it in brackets like this, multiplied by 5 multiplied by 3. And if we multiply those out, let's use a calculator. So we have 6 by 5 by 3. So it's equal to 90 centimeters cubed. Okay, so it's always important as well to remember the units and to use the units as well. So that's just using, so that's volume, and that's using that formula. So again, this is another type of question. So again, very similar. So except you're just dealing with a cube. So a cube has a side length of 4. So its length is 4. Find its volume. So if we remember, volume of a cube is going to be equal to, so volume is equal to length cubed. So what does that look like? So it's going to be equal to, volume is going to be equal to 4 to the power of 3, which is equal to 4 by 4 by 4, which if we multiply these by each other, 4 by 4 is equal to 64 centimeters cubed. So that's that one. Again, we're just using this volume. So the volume of cube, use this formula. And let's think about the next one. So if you think about, like, so it's 64 centimeters cubed, that's the capacity. That's the volume or the capacity of this particular shape. It's how much volume that this shape can take or it can hold. So let's look at this one. So what we have here is a rectangular box. A rectangular box base of length 6 has a base of length 6 centimeters and breadth 4 centimeters. The volume of the box is 192 cubic centimeters. So find the height of the box. So what you've been asked to do here, so this is a backwards type question. You've been asked, you need to understand the formula to be able to do this. So if we think about what so volume, so what we're dealing with, so the formula we use, it's going to be this one here. So volume is equal to length by breadth by height. Now, what it tells us, so it tells us that the volume is equal to 192 length L is equal to 6 centimeters, breadth is equal to 4 centimeters, and then what you're looking for is height. Height is the unknown. So what you can do is you can fill this out. So we can look at it like this. We can say length by breadth by height is equal to volume. So we can put in what we have. So we have length. So length is 6. So it's 6 by breadth, which is 4, by height, and we'll just leave it as h, that's the unknown, is equal to 192. That's 192 cubic centimeters. Now what we can do is we have to work this out and manipulate our formula. So we can get rid of the brackets here, so we can multiply this out. So 6 fourths is 24, and 24 by h will be 24h is equal to 192. So now what we want to do is we want to get rid of the 24. We want to get h on its own. So this means 24 multiplied by h. So if we think, so we have multiplication, the opposite of multiplication is division. So what we have to do is we have to turn this 24 to a 1. So in order to do that, we have to divide this side by 24. If we divide one side by 24, we have to divide the other side by 24 as well. So that will go in there once, that will go in there once. H then is going to be equal to 192 divided by 24, which, so 192 divided by 24, so it's equal to 8. So the height is equal to, so that will go in there once, that will go in there 8 times. So the height is equal to 8 centimeters. And just remember to use the correct unit as well, centimeters. So that's that one. And let's go look at the last one then. Change the color. So a cube has a volume of 15.625 cubic centimeters. Find the length of its sides. So if we remember with this one, so volume is going to be equal to length cubed. So again, this is going to be like a backwards type question, okay? So we have volume is equal to 15.625 centimeters cubed. So we just put in what we have. So what we can say is we can rewrite this. We can say that length cubed is equal to the volume, which is 15.625. So now what we want to do is we want to get rid of this. Now if we think about when we're dealing with indices, so let's say if I have a to the power of 3, the opposite of that, okay, is going to be the third root of it. So if I have a to the power of 2, the opposite of that is going to be the second root of it. So essentially what I need to do is, in order to get rid of this cube here, I need to get, I can divide this by, or get the third root of this. So what will happen is these will cancel out, and I also need to get the third root of this. Okay, so what's going to happen, so this and this will cancel out, so the length is going to be equal to the third root of 15.625. So essentially, in order to get the length then here, what you need to do is you need to work out what the third root of this is. So you can just use your calculator to do that. So if you get your calculator, so we can use the calculator here. So what a second. So again, so this is the second root, so this is just the square root, and then this is the third root. Okay, so some calculators will have it like this. This is just normal square root, and then this is the third root. Sometimes it might have it like this, so you can get the fourth root, the fifth root, the sixth root, whatever. You can just put in the values that you want. But basically what you're doing is if you get the third root, so it's 15.625. Now what we want to do is we want to get the third root of that, because that's what we're looking for. So we can hit that, and it's 2.5. So the third root is equal to 2.5. So therefore your length of your cube is equal to 2.5 centimeters. 2.5 centimeters. And again, that's so like these are the kind of questions that you could be asked. You could be asked like straightforward ones like these two, where you're just using the formula. But not only you need to know how to use the formula, but you need to understand the formula as well. And you also need to be able to manipulate the formula in case you don't have one of the other parameters. Okay, and let's have a look at this one here. So what we have, let's just change the color. So what we have then, we have the triangular prism shown has a base of 6 centimeters and a length of 12 centimeters and a perpendicular height of 8 centimeters. So what you need to do is find the area of the triangular cross section. Okay, so you need to get the area of the triangular cross section, and that's that part, and then find the volume of the prism. Now, if we remember this, where is it? So this here. So if we can get, so I'll just bring these down here. Bring this down here. So we're looking at it. So we can find the area of any prism. The first thing you need to do is you need to get the area of the cross section. So in this case, the cross section is a triangle. So what you're essentially trying to do is you're trying to get the area of the triangle. So let's say so there's a triangle there. So that's the cross sectional face of the triangle. That's the cross sectional, or the cross section, or the area. We want to get the area of this cross section. Once we know the area of a cross section, what we can do is we can just multiply that by the height. So if you were to take this prism and stand it up on the triangular part, let's say, this 12 centimeters is going to be the height. And this is important as well because you'll get asked this type of a question, but you'll have the end of the prism will have a different shape. So you need to understand how to get the area of the end part, whatever that shape is. Now in this case it happens to be a triangle. Now if we remember when we're looking at triangles, what's the area of a triangle? It's going to be area of a triangle is equal to half the base multiplied by the perpendicular height. So it's half the base by the height. So we can see here that the base is 6 centimeters and the perpendicular height, so that's coming up from the base, is equal to 8 centimeters. So what we can do is we can use this to get the area of the cross sectional, the cross section of the triangle. So it's going to be, so therefore it's going to be area is going to be equal to a half of the base, which is 6, multiplied by the height, which in this case is 8. So if we multiply that out, that's going to be equal to 3 by 8, and 3 multiplied by 8 is equal to 24. 24 centimeters squared. Remember, we're just looking at the area of this. So now once we have the cross-sectional area, we can use this formula here. So the volume is going to be the area. So the A is the area of the cross-section. And the cross-section in this case is a triangle. So now what we can do is we can use this formula. So if we take the height of this prism is going to be 12 centimeters. So all we do is we take this area that we found and we multiply it. So the volume is going to be equal to the area, which is 24, multiplied by the height. So this is our height, this is our area. So the height then is going to be equal to 12 centimeters. So if we multiply those out, calculator, so it's going to be 24 multiplied by 12, which is equal to 288. So this is equal to 288 centimeters cubed. And very important that you use the right, that you get the right units as well. So again, just really important, this formula. You can use this formula for any prism. So just figure out what the cross section is. In this case, it was a triangle. Get the area of that cross section using whatever formula you have to use. So in this case, we use the formula for getting the area of a triangle that we've already looked at, and then you can just multiply it then by the height. So that is so that's volume. So it's how you get, so it's volume. So we've looked at volume, and it's the volume of, how to get the volume of prisms. Okay, so hopefully that made sense, and what I'll do is I'll put up some work for you. Okay, thank you.